All right, what up, everybody? This is Mr. Stan coming at you with a physics video. This time we're talking about friction, right, and the force of friction. So, friction, once again, is a force that opposes motion of an object. Its direction is always opposite the motion. Right, so as we started to learn yesterday, there's two types of friction when we're talking about like something sliding on another surface. There's static friction, which is when something's not moving, and kinetic friction, which is the friction of something that is moving. Okay, so depending on whether the object is moving or not moving, you either have static friction or kinetic friction. And we have equations for both these frictions. And so let's look at what these equations are saying. The force of friction is equal to, and then you see this weird looking symbol here. It's actually the Greek letter mu, but it stands for some number that represents how rough two surfaces are together. So if two surfaces are really slippery, like for instance ice on a marble table, then um, you'd have a very low number here. It's called the coefficient of friction. You'd have a very low coefficient of friction. If you had a much rougher surface like sandpaper or something, you'd have a much higher coefficient of friction. So anything below like zero point 0.1 is considered slippery, and then numbers closer to 1 or even above 1 are considered very rough. And so the smaller that number is, the less friction you're going to have, and the larger number it is, the more friction force you're going to have. So that number gets multiplied by the normal force, right? And that gives us how big the force of friction is. So anytime we want to find the force of friction, we're going to have to, using this equation, we're going to have to find the normal force, and we're going to have to know the coefficient of friction. All right, so the equation's the same whether you're finding static friction or kinetic friction. The only difference is there's going to be a different coefficient for each one. So usually the coefficient of friction for the static friction will be higher than the one for kinetic friction. Okay, so when you see these symbols, that's what it's talking about. It's just a number that tells how smooth or rough two surfaces are. Okay, so let's look at an example of finding the force of friction in an object that's not moving. Skye is trying to make her 70-kilogram St. Bernard go out the back door, but the dog refuses to walk. If the coefficient of static friction between the dog and the floor is 0.7, how hard must Skye push in order to move the dog? Okay, so to start, remember we can't really find the force of friction using our equation unless we know the normal force. The normal force is in that equation. So we're going to try to find the normal force first. So we're going to look at the vertical forces on the dog, right? And because the dog is balanced at this point, those vertical forces must equal 0. And so using the techniques of last chapter, we're just going to plug in the forces Fn minus Fg. Fn is the force that's going up, minus Fg is going down. Okay, replace Fg, the force of gravity, with mass times gravity, right, as it equals the same thing. Okay, the mass of the dog is 70, and then G is 10, as it's on planet Earth. Multiply those together, and then do a little bit of algebra, you'll find that the normal force is 700 newtons. Okay, so once we've done that, we have what we need to know for our equation to find the force of friction. Right, and the force of friction is equal to the coefficient of friction times the normal force. Does it tell us what the coefficient of friction is? Yes, it does. Right, it says if the coefficient of static friction between the dog and the floor is 0.7, how hard must Skye push? So we'll put 0.7 in for the coefficient, and then 700 in for the normal force. And that tells us that the friction force is 490. So we can put 490 right here. We haven't answered the question yet, because notice the question asked, how hard must Skye push? So we want to know how hard she's going to have to push this dog to overcome that friction force. And so to do that, we're going to look at the horizontal forces. So when you think about it, she's going to push harder and harder, and finally the dog's going to accelerate. What we're going to do is find out how hard she had to push right before it started to accelerate. And so we'll treat this like a balanced force problem, where 490 is going to be the force of friction, and we're just going to find the FP, the applied force. So set the horizontal forces equal to 0, right? And then FP minus FF would be our equation. We know that FF is 490, so we'll put in 490, do a little bit of algebra, and we'll find that the applied force would have to be 490 newtons. Okay, so the maximum friction force the dog's going to have when it's still is 490. If she pushes at 490, it's still balanced, but any force greater than 490, and the dog will start to accelerate. Okay, now for an example of finding friction on something that's moving with a constant velocity. Okay, so going back to the same dog, she's trying to make the 70-kilogram St. Bernard go out the back door, but the dog is still refusing to walk. If the coefficient of kinetic friction between the dog and the floor is 0.5, how hard must Skye push in order to move the dog with a constant speed? So remember, in the previous problem, the coefficient of friction is 0.7 because the dog was still. Now she's got the dog to start sliding along the floor, and so we're dealing with the coefficient of kinetic friction, meaning it's moving, not the coefficient of static friction anymore. And as usual, that number is going to be a little bit lower. So she would have to use less force, right? So we expect a number less than 490 this time, and let's see how it works out. So the first step would be basically the same as before, right? We need to find the normal force, which hasn't changed, right? It's still 700. And then we'll put that equation, and we'll put the normal force into this equation to find the friction. We have a different number for the coefficient this time because it's moving, and the problem tells us that that is 0.5. So let's put those numbers in. Okay, and we get that the friction force is 350 newtons. We haven't quite solved the problem yet. She's pushing him at a constant speed, so the horizontal forces should be balanced, which means we can use our balanced force equation to find FP, or the applied force. Okay, and so we've set Fx equal to 0, and then Fp minus Ff are the two horizontal forces. We know that Ff is 350, so we just do some algebra and we find that the applied force is 350 newtons. So that's our answer, right? She had to push with 490 newtons when the dog wasn't moving. Once she gets the dog moving at a constant speed, she can push with 350 and he'll keep that speed. Okay, so one more example we haven't looked at, and that is friction with acceleration. So let's look at that. All right, so this time Skye is getting angry with this dog, and then she pushes it hard enough that it accelerates at 1 meter per second. If the coefficient of kinetic friction between the dog and the floor is 0.5, like last time, how hard is Skye pushing on the dog? So this time she's starting to accelerate the dog. So it's no longer going to be a balanced force equation in the horizontal, right? It still is vertically, but not horizontally. We're going to try to figure out how hard she's pushing. So before we can figure out the friction force, we have to figure out the normal force like last time. It has not changed. It's still 700 using the same technique. The vertical forces of the normal force and gravity have been balanced the whole time, regardless if the dog's still or moving horizontally. So now we can put our number for the normal force into the equation. All right, so for Fn, we'll put 700, and then for the coefficient of friction, we're going to put 0.5 as the question gives us. The force of friction is 350 newtons. So notice that regardless of whether the dog is accelerating or moving at a constant speed, this friction force didn't change. Okay, what is going to change is the applied force, because now she's not applying just enough force to keep it moving. She's applying enough force for it to accelerate. So how would we solve that? Well, watch carefully this next step. Before, when we're solving balanced force equations, we would say that the sum of all horizontal forces would equal 0. Okay, but this isn't balanced, so we're not going to say it equals 0. It's going to equal mass times acceleration. And that's Newton's second law. Right, and so the mass of the dog is 70 kilograms, and she's pushing it with an acceleration of 1. So 70 and 1 are going to go into this equation. Right, and then we do the algebra, so still Fp minus Ff, but instead of equals 0, it's going to equal 70. And then doing the algebra, you see that the applied force is 420. Right, so go ahead and if you need to rewind and look through any of that and pause it, again, go ahead. Hopefully this helps you with today's worksheet, and I will see you all soon.